right. Region R is enclosed by this curve. What's the volume of the solid generated when it's rotated around the y-axis? If we're rotating this around the y-axis, what type of a problem is this? It's a washer method because it has a hole in it. Okay? So the washer method is from the lowest point to the highest point. So from 0 to 8, because we're going around the y-axis, pi is in front, and then you can take the far curve minus the near curve. But because we're going around the y-axis, we have to solve for x. So solving this one for x, 2y equals x squared. So x equals the square root of 2y. Solving this one for x, y over 2 equals x. So it's the square root of 2y squared minus y over 2 squared dy. Then I grab my handy dandy calculadora. And I go I go math 9, 0 to 8 of the square root of 2y squared is just 2y, or in this case 2x when I'm using the graphing calculator, minus x over 2 dx, enter, and we get 48, so it'd be 48 pi. Give exact answers in terms of pi, so 48 pi. Did I square the y over 2? No, I didn't. I'm a Dummkopf. So, enter. Second, insert, parenthesis, squared. Try that again. Math, turn it into a fraction, please. 64 pi over 3. Thank you for 64 pi over 3. There we go. Okay? All right. All right. We want to know the area bounded by this curve. Well, it's already solved for x, so that really helps us out. So it's just the integral from the bottom to the top, 1 to 2, of y cubed plus 8 dy. Math 9, negative 1, that's a negative 1 here. So negative 1 up to 2 to y cubed plus 8 dy. And 27.75. All right, the base of a solid enclosed by a graph is this and this between the y-axis and 4. Cross sections of the solid perpendicular to the x-axis are rectangles whose heights is this. Okay? So what I would do is I would graph these two lines out. So I'd go y equals, plot out 2 plus x over 2. And the other one is 2 raised to the x over 2 power. Graph. All right. So this one here is the top curve. The other one goes like that. So we want solids for this. Okay. So we take the top minus the bottom. So we take this minus this. So we get rid of this answer, and this answer. Wow. Because the top minus the bottom. So it's just answer D. Okay. The function B sub t gives a number of books sold by a store by time t in days on a given year. What does this represent? Because it's the first derivative, it is how fast they're selling from 45 to 50. So that would be the rate of change of selling books, because it's the derivative. Because it's definitely not that one. Definitely not that one. So it's either C or D. The number of books sold between there, because you take the integral of the change of the amount, and it should give you the total number or rate. I think it's C, actually. Or is it D? Derivative. Yeah, so you're counting the total number that changed. If you're counting the total number that changed, then that's how many sold. I'm pretty sure it's C. Consumer surplus is the amount of money consumers will save because they're able to buy a product at a lower price than the higher price that they would be willing to pay. Consumer surplus for a particular product is that. How many dollars does a surplus increase between 7 and 10? Okay. So if we integral it from 7 to 12 of 900 over x plus 13 minus 35, so then if we integrate that, it would be 900 times the natural log of x plus 13 minus 35x. And then you're going from 12 to 7. So it's 900 ln of 25 minus 36 minus 900. Okay. What? 35 times 12 is a big number. What's 35 times 12? 420 minus 900 ln of 20 minus 35 times 7? 245, yep. All right, so if we distribute the negative sign, negative 420 plus, so this would be negative 175, and then 900 ln of 25 minus 9, so it's 900 ln of 25 minus 900 ln of 20 would be 900 ln of 5. Oh, but we divide, so it's 1.25. Because when you subtract natural logs, you divide. So 25 over 20 is 1.25 minus 175. So it'd be D. All right. That one was a little ugly, but we made it through it. Particle moves in a straight line with velocity of t, where t is time in seconds. at t equals 2, the particle's distance was 10 meters from positive direction. Was it at 9? So at 2, it's 10 away. And then you go from 2 to 9, the integral of the velocity. Okay? So you really don't need the graph there. It's just the wording of it is all you need. The base of the solid is this, and it's semicircles. Oh, joy. 1/8 pi r squared is the total distance across. So it's the integral from, and then we're going perpendicular to the x-axis. So if we're perpendicular to the x-axis, it's from here to here, and we got to figure out where it ends. X equals 1. Okay, well then that's easy. So from 0 to 1 of 1/8 pi, and if it's a radius, this distance across is this, so you take e to the negative x divided by 2 to find the radius. Is it pi r squared or is it pi d squared? Okay, let's figure this out. A semicircle. So if this is a radius, then this is a diameter. So the semicircle is 1/2 pi r squared. So if it's a diameter is half the radius, so you take 1/2 pi, and then you go d over 2 squared. So it's 1/8 pi d squared. Okay. So it's d squared, so it's e to the negative x squared. There we go. So you go 1/8 pi, the integral from 0 to 1 of e to the negative 2x. Well, u equals negative 2x. What's du going to be? Negative 2 dx. So you need a negative 2 dx here. So if you put a negative 2 there, you need a negative 1/2 out front to counteract it. So the integral of this is e to the negative 2x from 1 to 0. And then you have a negative 1/16 pi in front. If you put in the 1, it's negative 1/16 pi e to the negative 2. If you put in a 0, it's minus e to the 0 is 1. This is our answer. That whole thing goes in there. What? Yeah, you know, this is the exact volume. And I know that answer ends up like that. The region bounded by this is just simply the integral from negative 4 to 6 of 12 plus x minus 1/2 x squared. You do it on your calculator, you get an answer. Easy peasy. Okay, this, you're rotating around the line x equals 5. Thus, it's a washer method around a different line. Okay, so it's pi. It's around a vertical line, so you have to go from bottom to top. So from 0 to 1 of, find the distance in between these two. The distance in between purple and blue is purple minus blue, or 5 minus 4 minus x. Or 5 minus 4 is 1 minus the negative x is 1 plus x. So it's 1 plus x squared minus, and then you have to go purple minus red, which is 5 minus, I got to solve for y. Got to solve for y here. Or, yeah, I got to solve for x. Yeah, got to solve for x because it's a vertical line. You guys are so smart. All right, so this one, if I solve for it, x equals 3y. So it's 5 minus 3y. And you put that into your calculator, and you should get an exact answer. If I put them in quick on second quit, math 9 from 0 to 1, I have 1 plus y quantity squared minus parentheses 5 minus 3y quantity squared dy. Math, turn it into a fraction, please. Negative 32 pi over 3. Why is it negative? Should be positive.
You didn't ever, did you change the first one? You only, like the blue line, is that in terms of?
Yeah, because if we move the x and move the y, x equals 4 minus y. So then it becomes 1 plus y. So, oh, it's the further line, it's this minus this. It's the further away minus the closer. Got those backwards. So then it'd just be positive of that. I'm betting, but I better do it just in case. It's further minus closer. So it'd be 5 minus 3x squared. And then minus, Mr. Bierschbach, not a negative sign, minus. And then 1 plus y. Yep. So 32 pi over 3. For this one, when you see one like this, you got to find this point, and I would find it to a whole bunch of decimal places. The reason why is then you have less rounding because you have round at 3 decimal places, so you have less rounding error. So we got to find out where those two cross. So you put them both in. So under y equals, one is 18 log base 10 of x, and it defaults to log base 10 here, so I don't have to put the 10 in. The other one is 0.5 x raised to the third minus 8x squared plus 34.5 x minus 27. Graph it. And then this goes over a little ways. So I'm going to change my window to -2 to 20 and -10 to 20 is fine. Graph. So that goes that way and that like that. Okay, so I got to find out where they intersect. Second trace 5. Figure out where they intersect. So go close to the intersection and push enter, enter, enter. So I'm going to go 4.5061649. And I don't need the y value, just the x value. Okay? And what I can do is I can store that value in for x. So I can say second quit 4.5061649, and I can hit the store button in for x. Store that as my x value. What? It stores a variable. It stores a number in for a variable if you want it to. Okay. And so, well, I guess I didn't really need to do that. Okay, so you want to go top curve minus the bottom curve. Well, the top curve is this one. So you want to integrate from 1 to 4.5061649 of top curve, which is y2 minus y1. And then I'm going to add on to that this one. So integrating from 4.5061649 to 10 of y1 minus y2. Math 9 from 1 to whatever my x is. Well, I can go second answer, yeah. Yeah, I can. I just hit enter there. And then I go second. No, I go vars. I go vars, y vars, enter, y2 minus vars, y vars, y1. dx. And then I'm going to go plus math 9 second answer up to 10 of vars, y vars, y1 minus vars, y vars, enter, y2 dx. And 104.644. Okay, this one. If you're rotating around the x-axis, you need a pi in front, and you're going from 0 to pi of the sine of x squared. So pi out in front, 0 to pi, sine x squared. There we go. The area of the region bounded by these two graphs, make this y1, this y2, and take the integral of where they cross of, well, let's just graph them. So x squared plus 2x plus 2, and then 2x squared plus 3x minus 4. We graph them. Zoom 6. Get them back to there. So they're going to cross each other at -3, I think. So we trace to -3. And that's where they cross. So we go from -3, And then they also cross at, looks like 2, trace to 2. So if we trace to 2, 210, they're both at 210. If we trace to -3, they're both at -3.5. So then we go to the top curve. Ooh. The top curve is, I think, the y. The top curve is f of x, so it's y1 minus y2. And you do that. So math 9. Oop, clear. Second quit. Math 9 from -3 up to 2 of vars y1 minus vars y2 dx. (125/6). Four over x is a graph that looks like this. We're going from y equals 5 to x equals -6 and x equals -2. So it's back over here. X equals -6 to -2, and g of x equals 5. So I think it must be this region we're looking at. So if we integrate this, it's the integral from -6 to -2 of the top curve, which is 5, minus the bottom curve, 4 over x. Okay? And since they have ln's in the answer, I'm thinking that we have to do this by hand instead on the calculator, because the calculator won't give it to us. Well, the calculator will give it a decimal, and you just type both of these in, but let's just do it by hand. So it's the integral of that, which is 5x minus 4 ln of x from -6 to -2. So it's -10 minus 4 ln of -2 minus a -30 minus 4 ln of -6. So -10 minus a -30 is -10 plus 30, which is 20, minus 4 ln of -2 over -2 times, because they're this is negative, be 2 -4 ln of 2 -2 plus 4 ln of -6, which would be 4, and then ln of -6 minus ln of -2. So ln of -6 over -2, which is ln of 3, 4 ln of 3. which then you put the 4 as a power. So it'd be 20 minus the ln of 81. 420 minus the negative ln of 81.
Why'd you make that power?
Because a number in front of a natural log goes to a power.
Oh,
Yeah.
I know that.
Yep. You should have learned that. Hey, Mr. Hodgen. Okay. Dang it. I was gonna try to, make fun of Comus, but I didn't have a chance to. Okay, where, oh, there we go. I'm here. Okay, almost done here. Region enclosed by that, and we're rotating around the line x equals -2. We're rotating around a vertical line. It's a disk method because we're next to it. So it's pi. The further line minus the closer line squared. We're going from 1 to 3, but we have to solve this for x because it's around a vertical line. So it's y squared minus 2 equals x. And we have to subtract the distance in between these two, which is, this one is at -2. And nope, all of this is squared because it's the difference. Because if it was the washer method, both of them would be squared, right? This is the disk method. So it's a solid disk here.
You just have to know that?
Well, because it's up against it. There's not a blank space in between. I did that again. So if there's not a blank space in between, it's the disk method, which do the subtraction squared. Because we can do the subtraction before we ever square it anyway. Plus a positive. So it would just be y squared squared, or y to the 4th, which is 1/5 y to the 5th from 3 to 1. So 3 to the 5th power is 243. So it's 243 over 5 minus 1/5, which is 242 pi over 5, without the use of a calculator, I think. The total number of subscribers Zhang Wei has for a video page is changing at a rate of this many subscribers. The time is 8 weeks. He has that many subscribers. How many does he have by week 20? You start at 120, and then you add on the integral from 8 to 20 of 21 minus 2t. That one. The average value is 1 over 5 minus 3, the integral from 3 to 5 of 6x squared plus 8. And then you just do it in your calculator. Particle with that velocity from 1 to 4, integral from 1 to 4 of 3 square root of t dt. Particle moves along the x-axis with that velocity. Position at 3 is 2. What's its position at 7? So you take 2, you take 3 plus the integral from 2 to 7 of t squared over sine squared of t plus 2. And you round it to 3 decimal places. All right, so we're taking a cross section, which is a rectangle, and the height is 4. So you take the top minus the bottom, perpendicular to the x-axis. So we're going the integral from 0 to 3 of the top minus the bottom, which is 4 minus x times, or minus x minus 2 squared. And then we're taking that times, taking that times 4 minus x. This is the base, this is the height. So 4 minus that squared out, 4 minus x squared minus 4x, so it's then plus 4x, and then plus 4, so it makes it minus 4. The 4's cancel. So negative x plus 4x is 3x minus x squared. So 3x minus x squared times 4 minus x from 0 to 3. All right. So that's we've seen so many of these problems this chapter. You will get a little frustrated with this test, but it'll make you better for Tuesday's test. And so when you're sitting in your house, note in on Monday, you can work on this a whole lot. I'm predicting that.